Hello guys, welcome back to this new video in my YouTube channel. So in today's video, we're going to solve the third question that came in June 2025 Math Mechanics. So I hope you have watched the first part and the second part. So this is actually the third part. That's why I wrote that question 3. So let us just get started. The question read, a block P, a block P of mass 4 kg lies on a plane inclined at an angle of 60 degrees to the horizontal. It is connected to another block Q of mass 6 kg, which hangs freely by means of a light inextensible string which passes over a smooth pulley at the top of the plane. Find the acceleration and the tension in the string if A. The plane is smooth, B. The, the plane is rough and the coefficient of friction between P and the plane is 3 on 5. Then take G as 10 meter per second squared. So that was the third question that came in 2025 Math Mechanics Part 3. So we are going to solve the question together, and as we proceed, pay keen attention please. So we are given two blocks. One hangs freely and the other one is on top of a plane inclined at 60 degrees, right? That means the angle of inclination is 60 degrees. So we have to conceive a diagram to represent actually this literature, because from our diagram we'll be able to analyze everything. So the first thing, to draw a diagram. So this is actually the diagram with all the forces. Okay, let me explain the diagram. Q is hanging freely and P is on the plane. The angle is 60 degrees from the equation. A block P of mass 4 kg lies on a plane inclined at 60 degrees. So P has a mass of 4 kg and it lies on a plane. So this is actually the plane. This is a plane here, 60 degrees. Hope we are okay. So this is block P. Perfect. Let us continue. To the horizontal, it is connected to another block Q of mass 6 kg which hangs freely by means of a light inextensible string which passes over a smooth pulley on top of the plane. So this is the top of a plane. We will just assume that there is a pulley somewhere here, and actually there's a pulley here, and block Q hangs freely. So this is how the diagram is supposed to be. From there now we are asked to find the tension and the acceleration. Find the acceleration and the tension in the string if the plane is smooth. Okay, the A part, the plane is smooth. If the plane is smooth, that means there's no friction. That means there's no coefficient of friction acting on the plane. In that case, okay, now for the forces, we know that since this tension is tough, since this string is tough, it means that the tension here will be acting towards this pulley. The tension will be acting towards this pulley. And same thing, this tension will equally be acting towards this pulley. So we are okay. Then now this is the weight of this block Q. The weight is the mass times the acceleration due to gravity. And the mass of block Q was found to be 6, was given to be 6, and the acceleration due to gravity is usually G. So that's why I hold the weight here to be 6G. Same thing here for block Q. The mass was given to be 4 kg. Then now on the acceleration due to gravity times 4 kg will make 4G. This is not 4 gram, please. It's simply 4G, where G is the acceleration due to gravity. Okay, so we have the tension there. Now, angle is 60. If you are to resolve this weight perpendicular and parallel to this plane, Perpendicularly, like this, we are going to have 4g cos 60. 4g cos 60 because this angle here, this angle, look at where this thing is going. This angle here is actually 60 degree. And since it is closer to this line, so that's why I make it 4g cos 60. And because this angle is far away from this parallel line here, that's why you have sine. That's why you have here 4g sine 60. Hope it's clear. Now we have a normal reaction force that's acting perpendicular to the plane equally. Okay, so that's all about the resolution of the forces. So we are now going to proceed with our calculations. The first thing we are going to take the motion of particle P, and we're going to apply Newton's second law of motion. That is, the net force acting on the system is equal to the mass times the acceleration. Now, for the motion of particle P, okay, I omitted something before we proceed. If you were asked that where is actually the acceleration of the system going, I mean, where is the motion going to? Is the particle going by downward or is going by this way? Actually, the particle will follow the motion will follow the particle that has the heavier mass. And the one with the heavier mass is this 6g. I mean, is this Q because Q is having a mass of 6 kilograms. So actually, the motion will be going by downward this way. You see now, so the motion will be going by, that means acceleration will be going by in this direction, downward, downward, downward. Okay, so in that case, if you are to follow P, for P, the force causing the particle to go upward with the tension force, and 4g sine 60 will be like a resistive force. So in that case, we're going to have the tension minus 4g sine 60 to be equals to 4a. That's the mass times the acceleration. The mass of particle P was found to be 4 kilograms and the acceleration is a. Hope it's okay. G was found to be 10. So we are going to have T minus 40 sine 60 is equals to 4a. But we know very well that sine 60 is root 3 on 2. So we are going to have T minus 40 root 3 on 2 is equals to 4a. Hope it's clear. Now, T will be equals to 4a plus 20 root 3 because 2 will cancel 1 and 2 will cancel 20 times. And it comes to become positive. Now, the motion of particle Q. Now, the only this remember this Q and remember the acceleration is going by downward. So the force that will cause this particle, this block to go down will just be the weight of the particle. And this tension force will be acting like a resistance, like a resistive force, not resistance, sorry, resistive force. So in that case, we're going to have 6g minus the tension force should be equals to 6a since the mass is 6 kilograms. So that is why, okay, so that's why I have 6g minus t because it's 6a. And from there, from equation 1, we have the tension to be equals to 4a plus 20 over 30 because actually the tension has to be the same in both blocks. So we have 60 minus 4a plus root 3 plus 20 root 3 is equals to 6a. If you open the negative inside the bracket, we're going to have 60 minus 4a minus 20 root 3 equals to 6a. We bring items together. We're going to have negative 10a is equals to, when this one crosses here, it becomes, okay, now when negative 20 crosses, it becomes positive 20 root 3. Now when 60 crosses, it becomes negative 60. When you factor out negative, you're going to have negative into 60 minus 20 root 3. Because if we actually open this bracket back, you're going to have negative 60 plus 20 root 3. From there now, you divide auto by 10, you realize that A will be equals to, by negative 10, sorry, you realize that A will be equals to 6 minus 2 root 3. And it simply means that acceleration will be equals to 2.54 meter per second squared as the acceleration of the system. Now, to have the tension, we simply take this acceleration and substitute in any of our equations. We can still substitute here. So in that case, we're going to have the tension to be equals to 4 into 2 into 3 minus 3 plus 20 over 3. So we're going to have the tension force to be equal to 24 minus 8. 24 because actually 4 times 2 times 3 is it's actually 24. Then now 4 times 2 times root 3 is minus 8 root 3. Then now plus 20 root 3. So if you compute this, we're going to have 24 plus 12 root 3. And we're going to have at the end of the day, our tension is equal to 44.78 Newton. You realize that basically I don't usually take care of about this algebra because the key point here was to resolve these forces and to know in which direction is the motion of the particle. Yes. But the good thing is that another student will decide and take by this direction as the motion. In that case, acceleration will be negative. Yes. So that's actually what you're supposed to do for question. For the first part of the question, where the motion is smooth, where the plane is smooth. Now, the second part, for the second part of the equation, we are given the same diagram, but the only difference is that there is friction. That is, friction is acting on this plane. So we know very well that this friction usually opposes motion, right? So in that case, the motion of this particle is going in this direction, that is downward like this, downward like this. Over at the core, this is how the motion of the particle is going, downward like this. Because block Q has a heavier mass than block P. If block P had a heavier mass than block Q, then the motion will be going in this direction like this, down the plane like this. But it shows that block Q can carry block P up. So that's why the motion is going by like this direction. Hope it's clear because most students usually confused. Okay, since friction usually opposes motion, if the motion is going this direction, then friction will be acting but in the opposite direction. So that's why the frictional force is in this direction. Mu n, frictional force, where mu is the coefficient of friction and n is the normal reaction force. Hope it's clear. Don't ask me that why is that the frictional force is not in this direction. No, it's in this direction because actually opposes motion. And the motion is going up, so the frictional force should be going down. Okay. So that said, we're going to apply the same rules where we're going to be resolving forces. So let's dive in. Motion of particle P. Okay, now for the motion of P, realize that the net force that's causing the particle to move up will be the tension force. And mu n and 4g sin theta will actually be resistive force. So we're going to have the tension minus 4g sin 60 minus mu n is equals to 4a. Where yeah, because we're actually applying Newton's second law of motion, where the net force of the system on this particular system is equal to the mass times the acceleration. Hope this one is clear. T minus 4g sin 60 minus mu n is equal to 4a. T because it's going up minus 4g sin 60 because this force is actually going down minus mu n because it's actually going down is equal to 4a. Perfect. Now, know that n is equals to 4g equals 60 because when we resolve perpendicularly to the plane, we notice that n is equals to 4g equals 60. This from Newton third law, opposite forces. That is, the net force acting on this side is because net force acting on this side, and the force acting on this side is n, and that is the normal reaction force, and the force acting here is equally is a resultant of this weight perpendicular to this plane. So that's why you have to n should be equals to 4g equals 60. Or otherwise, you could still decide and take n minus 4g equals 60 is equals to 0. Yes, Newton third law still. Okay, since we had our n to be equals to 4g equals 60, we already know the value of g. We know that g is 10. So let us replace everything here. We're going to have t minus 40 sine 60 because g is 10 minus, okay, now the coefficient of friction was found to be 3 on 5. So you have 3 on 5 times 4g equals 60 is equals to 4a. In that case now, you have t minus 40 sine 60 is 3 on 2 minus 3 on 5 times, okay, now g was found to be 10. So here we're going to have 40. Then cos 60 is half. So 40 times half, you're going to have 20 is equals to 4a. Hope this point is clear. This is actually algebra. Here we're going to have t to be equals to 4a plus 20 over 3. Then now 5 divide 24 times. Then now we're going to have, 20 divide 5 4 times. Then now we're going to have 4 times 3. That's 12. Then cos it become positive 12. Perfect. So now the motion of particle q, actually particle q will not really change. The net force forcing this particle to go down with the weight, that's 6g minus t will be equals to 6a. Okay, so you have 6g minus t is equals to 6a. Now we are going to replace the value of the tension. We have 60, the tension was found to be 4a plus 20 over 3 plus 12. So we have 60 minus 4a plus 20 over 3 plus 12 is equal to 6a. When we open the bracket, we're going to have 60 minus 4a minus 20 over 3 minus 12 is equal to 6a. Okay. Here we're going to have 6 minus 12, that's 48, minus 20 over 3. When it brings 4a, this side become positive, so you have 10a. We divide by 10 now. We're going to have the acceleration of the particle is equal to 4.8 minus 2 3. So if you compute this, you're going to have the acceleration to be equal to 1.34 meter per second squared. And you realize that if you are to compare the acceleration of this second motion with the acceleration of the first motion, you realize that the acceleration of the second motion is smaller compared to the acceleration of the first motion. Because the first part, our acceleration was found to be 2.54, but now our acceleration here is rather 1.34. Now the question is, why is the acceleration small? You guys will answer that question in the comment section. Okay, now let us just go further and look for the tension. To have the tension, you just substitute that situation in any of the equation. So the tension will be equal to 4 times 2 into 2.4 minus root 3 plus 20 root 3 plus 12. And if you do this, you're going to have this, and your tension force will be equals to 51.98. Now, you have to compare this tension force with the first tension force. You realize that this tension force is actually bigger because the first tension we had was, let me check, 44. Yeah, we had 44, approximately 44.7 or 0.78, yes. But here we're having, we're having a tension force to be 59. So there is a difference of approximately 7 Newton. Okay, so you guys will answer, why is that the tension here is greater than the tension there, and the acceleration here is smaller than the acceleration in the first part? Okay, so feel free to comment in the comment section below, and thank you guys for watching. And if you are new in this channel, make sure you subscribe for you not to miss the subsequent videos that are coming. Okay, so see you in the next tutorial, and thank you for watching.